Hi, I'm Papia. In this problem, we have to find the zero of this function that's given to us, x cubed minus 3x squared plus 3. For part A, we have to use the intermediate value theorem and the table feature of a graphing utility to find intervals 1 unit in length in which we know for sure that the function will have a zero. And then in part B, we have to adjust that table so that we can actually determine the zero of this function to the nearest thousandth. Okay, so let's start by finding an interval that will be 1 unit in length where the function will definitely have a zero. So pick a graphing utility that you have and write down the function x cubed minus 3x squared plus 3, and then in the table you can start at any x value that you want. Let's start with a negative value, say x equals -3, and then make sure that your length of the interval is 1. Okay, now you have the table in front of you. Look at the y values. Now notice that when we are using intermediate value theorem, it's not the value that we are interested in for the y, but it's the sign that we're interested in. So locate where the sign is changing. So you see that from at -3 you have a negative, then -2, we also have a negative, -1, negative. At 0, we have a positive value. So we have a change in sign right here between -1 and 0. Now, recall, what does that mean? Well, this is what it means. If you are thinking about the graph of this function, okay, at -1, the function is, the value of the function is something negative, right? At 0, the value of the function is something positive. Now, the function is a polynomial, so it's continuous. That means the graph of this function has to join these 2 points, right? And that means the function has to cross x-axis somewhere in between -1 and 0. That's intermediate value theorem. So we know it is guaranteed that this function will have a 0 inside this interval, -1 to 0. So that's the answer to our first part. So we got our interval 1 unit in length, and the interval is -1, 0. Notice that I did not put close bracket because I know that the function is not 0 at these 2 points. Okay, so there is a 0 inside this interval for sure. Now, let's see if we can find that 0 to the nearest thousandth. So what we have to do is you go to your table feature again, and then you plug in the left end point of this interval, -1. And let's make the length to be 0.1. So now we want to see between -1 and 0 where we have the function changing its sign. Okay, so if you do that, start from -1 and change the interval length to be 0.1. Okay, look at your table again and locate where the function is changing sign. Well, I see that when x is -0.9, function value is negative. When x is -0.8, function value becomes positive. Remember, we don't care about what the value is the sign. So we know that now the 0 lies between this interval, -0.9 to -0.8. Okay, let's change your table again. What should we do now? Well, go to your table feature and now plug in -0.9 as the starting point. And change the length of the interval to be 0.01. And hit enter. Okay, so we see that the next table, look at where the function is changing sign. Okay, so we see when we have negative 0.88, the function has a negative value, and when x is negative 0.87, the function has a positive value. Again, that means using the intermediate value theorem, our interval is between negative 0.88 and negative 0.87. So the 0 lies inside this interval. So we're making the interval smaller every time. Okay. Move on. Let's try again. Remember, we have to find the nearest thousandth, so we have to do at least one more time. So now, in your table feature, plug in the starting number to be negative 0.88 and change the length of the interval to be 0.001. Okay, so we get at negative 0.88, the function value is negative. At negative 0.879, the function value is positive. So now our interval is between negative 0.88 and negative 0.879. Let's try one more time and then we will have our answer. So again, start with negative 0.88 being the first value, and the length, change the length of the subinterval to be 0.0001. Okay, so scroll down. Remember, we have to locate where the function is changing its sign, and we see that negative 0.8794 function is negative, and negative 0.8793, the function is positive. Therefore, the 0 lies inside the interval negative 0.8794 and negative 0.8793. So we can say that the 0 of this function to the nearest thousandth is right here, negative 0.879. So we found the 0 to the nearest thousandth. So notice that we did find one 0 of this function, but if you look at the expression for the function, it's a degree 3 polynomial. So there are two other zeros. So we have to locate those zeros as well, and we can do the exact same thing, exact same method. If you go back to this very first table, and if you scroll down, go farther down, you see that the function value will change its sign 2 more times. One between 1 and 2, that's one time, and then between 2 and 3. Therefore, the function will have a 0 in each of these intervals, and that's again using the intermediate value theorem. So what you can do is you can next pick this interval, say 1 to 2, and then you follow the same method and you can locate another 0. And the 0 that you will get, again nearest to the thousandth, is 1.347. Similarly, you can pick this last interval between 2 and 3 and follow the same method, and you will find the third 0, and that one is 2.532. So this way, you can use intermediate value theorem and the table feature to find all 3 zeros of the polynomial. Thank you.